Got a fire tank. It's 12 feet across, 4 feet wide, and 5 feet high. What shape is that?
Trapezoid.
A rectangle
Trapezoid.
prism.
Trapezoid. Where do you get trapezoid?
A rectangular prism.
I don't know.
Why would you guess trapezoid? I guess I'm just curious.
Because, well, what's width? Is width the bottom length?
Yeah.
Okay. If the bottom is less than like the top, wouldn't it, like the bottom be smaller so the sides have to come in like this? Okay, because you said the top was 12 feet across.
Yeah.
The bottom is 4.
I'm just trying to see why you get that out of there. When you have trapezoid, there's going to be two tops. One's got a different size than the other.
Yeah, I thought that's what it was.
Well, they're 12 across the top, 4 feet wide, and
Maybe I just don't know.
It's like
what it is.
12
We should just
feet,
do
and then it
that.
goes back 4, and then up 5.
so I've got 12 feet is here, 5 feet high, so I got a rectangular face on it, and then it's going to go back 4. And you could draw this a couple different ways. It's a possibility, but you should still end up with the same answer. All right. Now, that's a prism, correct? So it says water's being pumped into the tank at 133.69 cubic feet per minute. We're using Swan Lake water, so it's green. It's coming in, and water's in here. Okay. So there's my water. It's coming in. Since it's a volume in a cubic part, it's a dV/dt. 133.69 cubic feet per minute. With me so far? Now, it says how fast is the water level rising? Well, where are you going to put the water level? Usually from the base up, so that's going to be my
5.
H, right?
Oh, yeah.
And so they're going to want dH dt when H equals 3. Alright, the container's the container. We're not worried about the container for our purposes, okay? It's just that's what it's inside. We got to worry about the water. Since we're talking volume, how can I find the volume of the green stuff?
Why do they want to know DHDT? I mean, don't they want to know the volume?
They know. We don't want to know volume. We want to know how fast things are changing. I just want to know that water level's rising at a certain rate. Might take, so how long is it going to take me to
Don't
get
we
to
use that equation
6
though,
feet or
for the
something?
volume?
Huh?
We use the volume equation though, right? To find
Well, yeah, you're going to need the volume equation
Why did you name the other rate DVDT?
because that's volume coming in.
I thought that was rate.
It is volume per time.
Okay.
Rate of change of volume.
Isn't that what we're looking for?
No, we're trying to find the rate of change of the height. Each variable has its own rate.
Okay.
Area change, radius change. Volume change, height change. Volume change, radius change. X changes, Y changes. So, I got to find a volume equation. Well, is it a prism?
Yes.
Yep. So, what's the area of the base? The base is a rectangle, right? So that's just 12 times H. Why did I just use 12? It's always 12, right? In some of the problems we've done with the cones or the cylinders, they change. Or, they got some different things in there when we're messing with it. In this case, it doesn't. It's still 12. So there's the area of the base. What's the depth? 4, right? Is that my volume equation? Maria's looking at me like I'm nuts.
Well, I thought you said to not worry about the container.
Well, I'm not, because I'm looking at the green line, that's 4, and that's 12 all the time.
Oh, I read.
Okay, so this, think of it more, a good analogy is a fish tank. You fill up a fish tank, and that water's always a nice little rectangular prism. And it's always 12 and it's always 4. The nice part about this is there's only 2 letters. This one's going to seem easier than you may want, but it's basically the same thing. Usually we've messed with finding a relationship between something. But in this case, we don't. I got that? I'm not done yet. I've just found my static equation, and I've got the related rate equation that I'm going to use to find the answer. And that's when I'm going to use the 3. But the funny part is, I think you just noticed, there's no h here. So the 3, it really doesn't matter. The rate of change is constant in this case, no matter where we're at. Because it doesn't matter on the height of the water. So I'm just going to plug in 133.69. And I got that. If I just divide everybody by 48, I'll have my answer. It's about 3 something.
2.79.
2.79 feet per